I received a question from Veronica Davison concerning the creation of site plans in DataCAD. Specifically, she asked about using DataCAD's bearing and distance input to create the property boundary, and said that sometimes it was difficult to pick a starting point and then be able to work all the way around and have the site close. Well, DataCAD's default settings are geared toward doing architectural floor plans, not toward doing site plans. So there's a number of default settings that need to be changed in order to input site information effectively. So let's go ahead and take a look at what some of these settings are before we get started in creating the site plan itself. Since we'll be entering the Surveyor data in decimal feet and bearings, as opposed to feet and inches and degrees, minutes, and seconds, we'll need to make a couple of changes in DataCAD's settings menu. So off of DataCAD's utility menu, you'll find a settings option. And within the settings menu, you've got an option for scale type. When I select scale type, we see that it's set to architectural. And this is DataCAD's US default setting. But for Surveyor data, you want to input distances in decimal feet. So the first thing I'm going to do is change it from architectural feet and inches to decimal feet. Now, Surveyor data is typically rounded to 2 decimal places. So I also want to change the number of significant digits from the default of 3 to 2 so that my distances appear correctly when I'm identifying line lengths. So I'll select significant digits at the bottom here and then change it from the default of 3 to 2. Then I'll back up with the right mouse button once, and that takes me to the main settings menu. Now the next thing I want to change is the angle type. When I select angle type, I see that it's set to normal. Well, normal is degrees, minutes, and seconds. But in the case of entering Surveyor data, I want to input bearings. So I'm going to change it from the default of normal to bearings. So now I'll be able to input distances in decimal feet and angles in the bearing format. Another setting I need to change is DataCAD's input method. By default, DataCAD uses relative Cartesian, and that's where you press the space bar, type in your X distance, press the Enter key to accept that value, and then type in your Y distance, and then press Enter to accept that value. Well, in this case, we want to start our line and then continue by entering the distance of the line and then its bearing. So let's right mouse button and back up to DataCAD's utility menu here and go to the Tools pull-down menu and highlight Input Mode. Now you can see that the default relative Cartesian is currently checked. And there are several other input modes that you can use in DataCAD, but for entering distances and bearing angles, we want to use relative polar. So I'm going to select relative polar, and now I've changed DataCAD's input method. Now as a footnote, you can use the insert key at any time to toggle the current input mode, so it's possible to switch from one type to another whenever it's appropriate. So now we're ready to begin inputting the Surveyor's data. For this example, I'm going to pretend that we don't have a DWG file that we can import. We don't have a scanned image that we can insert as a bitmap and trace over, but rather we have a Xerox copy or a blueprint, and we're just going to read the values directly from it. So to demonstrate, I'm going to recreate the site plan that I've already drawn. So I'm going to pan the drawing to the right, and you can see that I've placed a marker in the drawing that coincides with the starting point I used originally. So I'll begin by object snapping to the marker that I placed. And then to input the first property line, I'll press the space bar, and DataCAD's going to prompt me for the distance. Well, reading from the Surveyor's plan, the distance of the first property line is 234.99 feet. After I type that distance, I'll press Enter, and now DataCAD's going to prompt me for the angle, or more specifically the bearing. In this case, the bearing is north 2 degrees, 58 minutes, and 57 seconds west. So all I need to do when I input the bearing is separate degrees, minutes, and seconds using decimal places and begin and end with the direction, northwest, for example, or southeast. So I'll press enter to accept that, and now I've matched that first property line along the west side of the property. Now I'll continue by repeating the same steps. I'll press the space bar, and again, reading from the surveyor's plan, the length is 46.72 feet. Then I'll press enter, and the bearing is south 41 degrees, 12 minutes, and 51 seconds east. Now, looking at the surveyor's data, I can see that the engineer was careful to set the angles or the bearings of all of these property lines in a clockwise fashion. So we begin by heading in a northwest direction, we continue heading in a southeast direction, and then we finish back in a northwest direction. Now, I have seen on occasion where surveyor's plans kind of mix and match the bearings. So instead of something heading southeast, it may be mixed with an input that's northwest. And if you just follow those directly, you may find your property lines going opposite to what you expected. So it's just a good idea to double check the surveyor's plan and see that you can essentially walk clockwise all the way around the site. So I'll go ahead and press the space bar, and the next segment is 80.6 feet. And then the bearing is south 49 degrees, 15 minutes, and 1 second east. Now I can continue using the same exact steps, but what most people don't know is that you don't actually have to hit the space bar to invoke distance input in DataCAD. You can just start typing a value. So for this next segment, I'm just going to go ahead and directly type the distance of 77.96 feet. When I do that, DataCAD recognizes that I'm inputting a distance value and automatically brings up the prompt. And when I'm done typing that, I can press enter, and then I'm prompted for the angle. So I'll continue. And I'll just keep going until I get back to the bottom of the property just before the curve, which we'll talk about a little bit later. Okay, so there's a perfect example. On the engineer's plan, the bearing was indicated as south 87 degrees, 32 minutes, and 2 seconds east. So, the distance and angle of the line is essentially the same, but it's heading in the opposite direction. So what's correct, it would be a bearing of not southeast, but of northwest. So I'm going to right click to let go of the line that I was drawing. I'm going to press the comma key to get rid of the last segment that I drew. And to restart, I'm just going to object snap to the last point that I drew. Now I've got one more segment before I meet up with the curve. And to enter the curve, we're going to be using a feature within DataCAD's curves menu called curve data. So I'll go ahead and enter the last straight segment. Okay. So let's look at DataCAD's curve data feature. I'm going to use the keyboard shortcut Alt-A for arcs. That will take us to DataCAD's curves menu. And within the curves menu, we have an option for curve data. When I select curve data, I get a number of inputs that I can use based on the information that I've been provided from the surveyor. So I may have the arc length, the radius, the delta angle of the arc, the length of its chord, its bearing in and out. But essentially it's like a game of fill in the blank until you have enough variables that DataCAD can figure out the remaining parameters of the curve. Before we continue, let's zoom in a little bit closer so we can get a better look at the arc that we're going to create. And I'm just going to go ahead and enter the data that the engineer has given me. So the arc length is 65.08. And the radius is 60. And you can see based on those two inputs, other properties of the arc have automatically been calculated. One of those values is the angle. If I select angle, DataCAD is going to display the delta down at the bottom of the screen of 62 degrees, 8 minutes, and 49 seconds. Now, according to the engineer's plan, it's actually 47 seconds, not 49 seconds. But depending on what order you enter the parameters, you're going to experience a certain amount of rounding. And in this case, 2 seconds is an extremely small angle. So I'm not going to concern myself with that right now. And I'll continue to add parameters so I can add this arc. Now the arc is always added in a clockwise fashion. So you want to keep in mind things like starting point and ending point, or bearing in and bearing out, with the notion that the arc you add is going to get added in a clockwise fashion. So with that in mind, I'm going to select start point, and I'm going to object snap to this part of the property line, because then the arc is going to continue from here in a clockwise fashion toward the other property line. So I'll object snap here. And I can see that there's still a number of parameters that need to be met in order to add the arc. Now, one of the parameters that I have, that the engineer didn't specifically give to me, is the bearing out. Now the bearing out is, tangent to this property line segment. Now the value that the engineer gave me is north 2 degrees, 27 minutes, and 51 seconds east. But that's heading, toward the top of the screen. The bearing out is actually opposite to that, not in a northeast direction, but in a southwest direction. So the bearing out is going to be south 2 degrees, 27 minutes, and 51 seconds west. Now I see for the first time the add option, and that's because DataCAD was able to calculate all the other parameters of the curve with the handful of variables that I entered. And I'll select add. And now DataCAD adds that curve, and I would say that looks pretty accurate. Now let's zoom in a little closer and see how closely the arc and the property line that it's tangent to match. So I can see there's an endpoint snap here, which gives me a clue as to where the arc ends and the tangent property line begins. And I'll just scroll in. And if I get in close enough, and this is far closer than you could ever see at any reasonable plot scale, we can see that they don't meet exactly. And in my experience, this is pretty typical because the engineer's data is rounded to 2 decimal places, or 1/100th of a foot, or down to 1/60th of a degree in seconds. So it's at this point that you just have to decide how you want to resolve this. Typically I would just leave it, but if you want to use DataCAD's trimming commands and so forth to clean these up and make them actually meet, you just have to keep in mind that the lines and arcs that you've entered that get modified in those trimming commands are no longer or necessarily going to match the engineer's data when you identify them. So what do I mean by that? Let's just zoom back out here. And identify some of these line segments. So I'll use DataCAD's identify command, which is Shift-I or capital I, and I'll select this property line. And we can see at the bottom of the screen that DataCAD's reporting back 234.99 feet. And that matches the length that the engineer indicated on their plan. The angle is north 2 degrees, 58 minutes, and 57 seconds west. And again, that matches the engineer's plan. So if I were to, use one of DataCAD's trimming commands to trim this arc to this line, I'm potentially going to end up modifying the length of that line or the length of the arc, therefore its delta angle, or the length of this property line. So then later on when I come back and identify it, say using Shift-I for identify and select that line, it may not come back with what the engineer indicated on their plan as 16.33 feet. It may come back as 16.35 feet or something like that. So I'll leave it to you to decide how you want to handle these situations. But in my own experience, I tend to leave the lines and arcs as I input them using the engineer's data, so that when I come back or someone else working with this drawing comes back and identifies the lines, they correspond to the original. Well, to continue with this plan, I next need to add some annotation. So I'll go ahead and talk about some different techniques for entering text around this property line. So there's a couple of approaches I can take to adding the bearings and distances to each of these property lines. One method I could use is just to input text. So I would just place the text cursor and then read from the plan and then just type those values in. Another approach I can take is to use DataCAD's measures command to select each one of these lines, have DataCAD report back to me what that information is, and then place it on the plan. So I'll start with just entering text. So I'm going to back out of the curves menu, and I've created a text layer, so I'm going to press the tab key and that'll bring me to the text layer. And then I'm going to go ahead and zoom into the upper portion of this site plan, and then I'll begin putting in my text. So to get to the text menu, I'm going to use DataCAD's hotkey Alt-T for text, and I can see that my cursor has changed from the standard cursor to the text cursor, also known as a caret, and I can see a little white plus sign at the bottom of the caret, and that indicates the alignment point. So if I select alignment, I can see that it's currently set to center bottom. And that's appropriate because I'm going to want to center each of the distances on each one of these line segments. So when I object snap the starting point of text, it's then going to center the results on the point that I picked. Well, the next issue I have is to get the alignment or the angle of the text parallel to each one of these segments. So within the text menu, there's an angle option, and if I happen to know what the angle of that line is, I could go ahead and type it here. But there's an easier way. I'll select match, and I've got a couple of choices here. I can just go ahead and select that line to match, or I can enter 2 points. Now 2 points is more explicit than just selecting the line because the action of picking those 2 points is setting the direction at the same time. So if I just pick this line, I get an angle of southeast. Well, that heading is correct. If that line that I selected returned a bearing of northwest instead, then my text would be heading in the wrong direction. So I'm going to right click to accept that angle, and I can see it there at the bottom of the screen, and I'm going to press enter. Now my text is parallel to that line, and I'm going to object snap to the midpoint of that line segment to begin my text. So I'm going to be entering the bearings on the outside of the property lines and the distances on the inside. So I'll go ahead and type in south 41. Now I need a degree symbol, and I don't happen to know what the Alt key combination is to enter a degree symbol. So I'm going to go ahead and enter the rest of the bearing, and then come back to that. Now for the distance, I'll just go ahead and enter that. And now that I'm finished, I'll right click, and we can see that those two values are now centered on that line segment. Now I still have an adjustment to make in terms of offsetting that text on either side of that line equally, but we'll get to that in a minute. Let's back out of the text menu and talk about this degree symbol. Now admittedly, the easiest thing to do is to know what the Alt key combination is for that extended character to enter that degree symbol. But it's worth knowing that in most versions of Windows, you can go to System Tools, and within System Tools, under Accessories, you can find the character map. So under Accessories, System Tools, Character Map, when I bring that up, I can now see all of the extended characters that are associated with a particular font. And the font that I'm currently working with is the DataCAD font. And here I can see a map of all the extended characters, and I can see the degree symbol. Now, when I hover over that, it gives me the Unicode value of that. That's that U plus 00B0. But it also gives me the keystroke value down here, which is Alt 0176. Now while I'm here, I can pick Select, and that'll enter that character into this input field here. And I can highlight those characters and pick Copy. So what that's going to do is copy that extended character to the clipboard so that I can use it in other places. So let's go back to DataCAD and use the change text command and get that degree symbol into my bearing. So the hotkey for change is Alt-C. That brings me to DataCAD's change menu. And to change text, I'll need to use the submenu Text. And then within that submenu Text in the change menu, I'm going to select Contents. So now I can select the entity to change, and in this case I'm changing text contents. So I'll go ahead and pick my bearing, and then down at the input line I can see that text highlighted, and it's after the 41 that I want to input that degree symbol. So if I press Ctrl V, it's going to copy that degree symbol from the clipboard into this input. And now when I press Enter, it's going to update that so I can see south 41 degrees, 12 minutes and 51 seconds east. So now that we know the Alt key combination for the degree symbol, let's continue entering our bearings and distances. So I'm going to go back to the text menu with Alt-T, and then I'm going to set the angle of my text to match this next line segment. So I'll select Angle, and then Match, and then pick the entity to match. I can see at the bottom that the southeast bearing is correct. I'll right click, and then Enter to accept that angle. Midpoint snap to this line segment, and then manually type in the value. So south 49. Now we want the degree symbol. So it's at this point that I'm going to enter the Alt key combination for that extended character, which is Alt 0176. So I'm going to press and hold the Alt key and then type 0176. And then sure enough, we get the degree symbol. And I'll continue with my bearing. of 15 minutes and 1 second east. I'll press enter for the next line and then enter the distance. And then right click to finish. Now I'll continue by using a different method to place the text. So instead of typing the values directly, I'll use DataCAD's Measures menu to identify each segment, have DataCAD report back to me what its angle and length is, and then input the values to the drawing. So I'm going to back out of the text menu and go to the Measures menu. You'll find that under DataCAD's Utility menu, but I'm going to use the hotkey for that, which is Alt-X. That brings me to the Measures menu, and I can select Line, which then allows me to pick one of the segments. DataCAD now identifies its length and angle, and I have an option to place that into the drawing. So the first value that I want to place into the drawing is the angle, so I'll select that. And now I get a subset of the text menu, and like we've been doing previously, I'll select Angle, Match, pick the line angle to match, right click and verify that the bearing of that is correct. In other words, the text will be headed southeast. Press enter to accept that, and then object snap the text to the midpoint of that line. Now I can continue by selecting Distance, and since I've already set the angle of the text, I don't need to repeat that step, and I can place the distance underneath the angle. I'll repeat those steps one more time. So to measure the length of another line, I'm going to right click twice to get back to the Measures menu, reselect Line, select a new line, put those values in the drawing, and the first value that I'm going to place is the angle. Now for the angle of that text, I want to match that line, so I'll select Angle for the text. I'll pick the Match option, select the line that I want to match. When I right click, I can see that that's bearing southeast. I'll press enter to accept that value, and now I can object snap to the midpoint of this line and enter the bearing. I'll continue by selecting Distance. The angle matches already, so I'll just left click and place the distance. Now the next method I'll use to annotate the bearings and distances on these property lines is going to take advantage of symbol attribute text. Now symbol attribute text is a complete subject unto itself and is beyond the scope of this video and is a topic I'll cover separately, but I'd at least like to demonstrate the utility of it in this example. So previously I've created a symbol that contains attribute text for the bearing and length. So let me reposition the drawing, and then I'll select the symbol from the symbol browser. Now when I bring the symbol out into the screen, I see the default strings for the symbol attribute text. And I've got the symbol insert options on the left hand side. And there's a couple of settings which are important. The first one is dynamic rotate, because I want to be able to rotate the text to be parallel to the line that I select. I have an option called fixed text on, and that's because I want the text to always be readable from the bottom or right side of my drawing. In addition, I have symbol scale enabled, and that's because I want the size of this symbol to adjust itself automatically for my plot scale. So let's go ahead and place this at the center of this segment. I'll object snap. And you can see as I rotate around this line, bearing and length is always readable from the bottom of the screen. So regardless of the orientation, it's legible. It also allows me to decide, do I want the length on the outside and the bearing on the inside? Or vice versa, do I want the bearing on the outside and the length on the inside? Well, I've been continuing with bearing on the outside and length on the inside. So I'll object snap the orientation of that symbol using the endpoint of the line. And because these are symbol attribute text entities, I'm now prompted for a predefined set of values. The first one is prompting me to enter the bearing and then enter the length. So I can go ahead and modify this text. So reading from the surveyor's plan, I see that it's south 30 degrees, 20 minutes, and 9 seconds, and a distance of 100. I'll go ahead and click OK. And now those simple text attributes are automatically updated. And I'll continue to do this a few more times. Again, snapping to the midpoint of this line. And then using the endpoint of the line to set its orientation. Now I'll just modify the default values. Now I'll continue adding these, but we're going to skip ahead so you don't have to watch me do every step. So the last set of data I need to place is for the arc information, and I've created another symbol with text attributes for that. So I'm going to right click to drop that symbol, and then go ahead and select the symbol I'll use for arc length, radius, and angle. And to place it, I'm just going to use the endpoint of the arc. And then for its orientation, I'm going to use the opposite end of the arc, which will essentially make the text parallel to the chord of the arc, and that's just a convenient angle to use. And I'll go ahead and enter these values. Now I just need to move that text into position, so I'll right click to back out of the Insert Symbol menu. Then I'll go to the Move menu and select Drag. I'll pick this entity to move and the point to drag from, and then I'll just position the symbol, what looks visually correct. So the last thing I'll talk about is cleaning up the text that we placed with the first couple of techniques we used. So I'm just going to use the / key, which is window in, and then I'm going to press F2 to recalc the screen, and we can see both near identical versions on the right and left. But in this upper portion of the site plan, these pieces of text still need to be repositioned. You know, the symbol attribute text is nice because its spacing is preset within the symbol. But in the case of the other text elements that I entered, they still have to be moved around a bit. So I'm going to window in again with the / key, and then just put a box around this portion of the site, and take a look at these two pieces here. So I'll right click to back out of the window in or zoom menu. So I essentially want to move this text and have half of the gap end up on either side of the line. So I can do that by going to the move menu. And the first thing DataCAD does is ask me for the first point of the distance to move. Well, they're invisible, but text entities do have handles that you can snap to. So in this case, the midpoint. So I'll object snap that as my first point. And then for the second point, I'm going to use the midpoint of the adjacent text. And I'll object snap there. Now DataCAD's telling me that the distance to move is 4 1/4 feet. But I want half that distance, so I'll use the distance divided by 2 option. DataCAD will divide that distance, and now I can pick each of these entities to move, and they're equally spaced on either side of the property line. Now I can select new distance and repeat the same steps with these pieces of text. Now for the next 2 entries, there's an extra step we have to take. So let's go down and look at these 2. Now unfortunately, in the toDrawing function, the text alignment options are not currently accessible. This is going to change with one of our next maintenance releases. But for now, I'll need to change the alignment of this text after the fact. So I'm going to go to DataCAD's Change menu, select Text, and then Alignment, and I'm going to change the text from whatever it currently is to center bottom. And then I can go ahead and pick the entity to change. So the 2 pieces of text on the outside need to be center bottom. Now the text below that, it would have an orientation of center and top. So I'm going to go back to the alignment parameter and change it to center top. And now I can go ahead and pick each of these entities. But I'm still not done yet because I need to center each of these on the text above it. And I also need to set its spacing appropriately. So the first thing I can do is just use the move command. And I'm just going to move from the midpoint of this text to the midpoint of this text. Then I'll do a new distance and repeat that down here. So now I've got the text on either side of the property line, and I've got it centered on each. Now I just need to nudge that text a little bit above and below each one of those lines. Well, to do that, I'm going to use DataCAD's tangent function. So I'm going to right click and back out of this move menu. And then I'm going to use the hotkey for tangents, which happens to be B. And in the tangents menu, I'm now prompted to select the line to draw tangent to, or which line do I want to draw perpendicular and parallel to. So I'll select this line first, we can see the cursor changes its orientation to match that line. And now I can right-click and continue working in that orientation. So now I'll go to the Move menu, and I'm going to set my distance to move. So essentially I'm going to be moving from this line outward, and we can see as I drag my cursor away from that point perpendicular and to the right, I can see that my X distance at the bottom is increased to a little over 10 feet. So that tips me off that positive X is to the right. So that's going to allow me to press the space bar and then type that distance. But of course I'm in relative polar right now. I would need to change my input mode before I continue. So I'm going to press the Insert key until I get to relative Cartesian. Now I can hit the space bar, and my X distance is probably just going to be, say, 2 feet or 2.5 feet or so. And my Y distance is going to be 0. So now I can pick the entity to move just above that line, and then select Invert to move the other. Now to repeat this process, I can just hit B again to go to tangents, select the next line, which sets up my orientation, and then right-click. Now the distance to move is still the same, and it's still relative to X. So I interrupted what I was doing by pressing B. I changed my tangents angle. When I right-clicked, that brought me back to the Move menu. So now I can select the entity to move, select Invert, and move the opposite. Now to cancel this temporary cursor orientation, I'll press B to go back to tangents and select Cancel. Now I can back out of those two menus, and I'm back where I started. Now I'll zoom extents. Now we've got two identical site plans. Well, certainly this video covers a lot of ground and many techniques, some of which are specific to entering Surveyor data, and a number which can be applied pretty much anywhere. I will be posting links so that if you want to download the drawing and the two symbols that I used, you can. As always, thank you for listening, and if you have any comments or questions, please post them in the space provided below this video.